Okay, we are going to work on elimination right now. This is just another form of getting rid of a variable so that we can solve. If you have not watched the previous video, I would watch that first before you watch this one. You won't be able to understand this one if you don't know what you're doing in the previous one. So let's start with this first one here. We're going to use elimination here, and if you've watched the previous video or if you were in class the previous day, you should be able to get this one. We are just going to multiply the top by 2. And so for the top one, we're going to get 6x plus 2y equals 14. We just distributed that 2 throughout the entire equation. Now that didn't change the equation, that just changed the way that it looks. Then I can basically cross that one out. Now I've got to decide, am I going to add or subtract to get rid of a variable? In this case, I'm going to add to get rid of the y's. So if I add, I'll get 8x. These will cancel out because a negative 2 and a positive 2 added together will make a 0. Equals negative 6 plus 14 is 8. So then we will get x equals 1 if we divided both sides by 8 there. I'm going to erase what I had up at the top here just to show you that now we are going to actually be plugging this back in to one of our equations to figure out what y is equal to. I'm going to plug it into the top one. So 3 times 1, that would be with my x there. So 3 times 1 is 3. And then we're going to add a y and make it equal to 7. 3 plus y equals 7. That must mean y is going to be a 4. And we have what we need for an answer there. Our x is 1 and our y is 4. If I wanted to make this into an ordered pair, because we're trying to figure out where the two lines cross, so that would be at a point, I would put 1 comma 4. Let's move on. Number 2 is something new. We haven't seen this yet, but you can't take 3 times anything to get 8, and you can't take 2 times anything to get 3. So in this case, we actually have to change both equations. So what I did, I've already done this, but I have multiplied the top by 3 and the bottom by 2. That way, when I distribute, my y's end up being the same thing. They end up being 6y and negative 6y. So now I'm going to add to get rid of my y's. So I'll get 25x equals 25. That must mean x equals 1. That's a lot of stuff right there. Maybe you want to pause and kind of look it over, but that's the first part. Now I can take that x equals 1 and I'm going to plug it in for this x up at the top equation. So I'll have 3 times 1, which is just a 3, minus 2y equals 5. Subtract 3 from both sides. Negative 2y equals 2. So y must equal negative 1. Our ordered pair would be 1, negative 1. And we are finished. Well, I should probably put parentheses around that, though. Okay, now we're finished. Number 3, same idea. I'm multiplying the top by 2 and the bottom by 3. I could multiply the top by 3 and the bottom by 4. That would get rid of the x's since they're a 4 and a 3. But I'm going to get rid of the y's in this case. As you can see, I did that already. I already distributed them below. And I am now adding these equations. So I'll have 17x, these will cancel out, equals negative 68. Well, divide both sides by 17 then, and we get x equals negative 4. Now I can take that negative 4 and I'm going to plug it in right there. So 3 times negative 4, which would be negative 12, minus 2y equals negative 10. Now we just solve. So add 12. Add 12 to both sides. Those cancel. We'll be left with negative 2y equals 2. Divide by negative 2. Y equals negative 1. So our ordered pair is 4, negative 1. Or sorry, negative 4, negative 1. All right. Number 4. Same situation here. I multiplied the top by 3 because there was a 3 down there, and I multiplied the 2 because there's a 2 there. It's going to end up making 6y and 6y. So since they're both positive, I'm going to actually have to subtract them this time. So I'll get x, they will cancel out, equals, if I subtract 3 minus negative 4, that's actually a positive 7. Already done with the x, now I got to plug it in for the y. So I'll have 3x plus 2 times y, which was 7, equals 1. So 3x plus 14 equals 1 minus 14 minus 14. 3x equals negative 12. Wait, did I do something wrong? Divide by 3, x equals negative 4. Is that right? I don't think that's right. I don't think that's... So maybe I did something wrong. I don't know. You get the idea. Oh, wait, what am I doing? I plugged it in for the wrong thing. I was going to say, this did not equal negative 12. I plugged it in for x, or for y when I should have plugged it in for x. Let me retry that. Okay, so again, we're going to plug it in for the x instead. So 3 times 7. I'm going to plug it into the top one, this one right here, that x, plus 2 times y equals 1. There we go. So this will be 21 plus 2y equals 1. Divide both sides, or minus both sides by 21. We get 2y equals negative 20. So y equals negative 10. There we go. Our point is 7, negative 10.